All right, everybody, welcome to this 33rd edition of the community call. My name is Rob. I'm an engineer on the Docs team, and I'm going to be hosting this call today. We're very happy to have all of you here, and we're looking forward to having a great conversation about a lot of different great things that are happening. I'm going to go ahead and go through and provide a little agenda for the day so we can see what we're going to be talking about. And then from there, we'll take off. Let me actually mute my Slack notifications real quick, and we'll just turn on Do Not Disturb here. Sorry about that. All right, there we go. So let's see. To begin with today, here's our agenda. We're going to be talking about dynamic routing for databases to begin with, and then we'll move into input validations for inserts, followed by Schema Registry updates. We have a very exciting panel today with 3 experts on different enterprise offerings and some things around security, performance, and observability. Additionally, we're going to have some updates on Mongo. So for all you NoSQL people out there, hopefully that's exciting. We have a community demo from a repo called Pysura, so a little bit of Python and Hasura coming together. And then finally, we have something I'm sure everyone is looking forward to, some very exciting things that we've gotten to see internally, which is a V3 demo. All right. Before I jump into the agenda and turn things over to our first presenter, I do want to talk about the fact that we are trying to be a lot more transparent with the open source repository. So if you were to go to GitHub, and there's actually a resource over on the right-hand side of the platform here, where you can find information about our milestones. So we've tried to outline things that we're working on currently, things that are going to be picked up very soon, and then some of the more exciting things that are coming down the pipe with Hasura v3. So take a look over there, look and see, what we've posted, what's coming down the pipe, and feel free to have some conversation with us as well. All right. So to begin with, we're going to go ahead and jump in here. And I have Suraj with us, who's going to be talking about dynamic routing for databases. So I'm going to go ahead and turn it over to him in just a moment, and we'll go from there. Suraj, are you there?
I'm super interested to give this demo because dynamic routing for databases has been a feature where we were getting a lot of interest, both from the community and from some of the enterprise customers and so on. So to brief about this feature or how this feature helps you is like this feature lets you route your GraphQL request to different database connections based on each request context. And before I jump on explaining more, I would like you all to think about the Hasura landscape or what Hasura does in the current scenario. So take an example that if you basically what Hasura does is it provides GraphQL API for all your data, right? And when I say all your data, it could be a database or it could be a REST API or it could be even a remote schema. When I take an example of a data source, and if you want to make the system even more performing, then probably what you would do is you would currently connect multiple read replicas to it. And then when you have configured a read replica or multiple read replicas, what Hasura does is Hasura will make sure that the requests are going to read replicas, read kind of requests are going to read replicas, and mutation kind of requests are going to the primary. And if you think about this logical separation here, Hasura decide where to go or which database connection to pick here, right? And from some of the questions that we were getting from the community and customers, those are like, what if I want different roles to use different databases or different database connection configurations? Maybe different database credentials also altogether. What if I want specific queries to use different database connections? Or what if I want to select a particular node group on of a distributed database for specific queries, right? So to answer all these questions, we are announcing dynamic routing for databases on Hasura. So I've been telling a bit about connections here, right? What do I really mean by connections? Currently, what Hasura offers is like two type of connections. One is the primary connection and the other one is read replica connections. And with this feature, what we are introducing is we are introducing a new concept called connection set. how do you route the request to different databases, right? So the way that we are that you can do it, the way you can do it is using connection template, which is again a simple Kriti template which you're already using in a lot of places in Hasura. So how do you create a new connection set? Because just like read replica, you can now also go to the data source configuration, and then you can add a connection with a connection set is something you can think of like a read replica kind of a thing with the named identifier. So you can point to that connection set when you're writing the connection template. Let's take a few examples. What if you want to use different database connections based on the type of requests coming in, or maybe based on the role of that particular user? So if you specify or if you configure this kind of a connection template, which I've showed in the bottom of the screen, and if you're making a GraphQL request with X Hasura role as a manager, then Hasura will evaluate this connection template and then query this database connection as manager. Or if your connection, if you're specifying the Hasura role as employee, then Hasura will pick this connection and then make sure that it goes to the correct database connection. What if it is a distributed database, and if you specifically want a node group to be connected when a particular role is passed on as the Hasura request, Hasura session variable? Or maybe if you want, you can also specify a session variable, and then based on that you can point to a particular node group. Okay, this is a very interesting use case, or maybe you can consider it as a custom template sort of use case. Uh, if you have a read replica, or if you have multiple read replicas connected to it, then what you can do, maybe if you want to route specific queries to primary rather than using the going with the default approach, then what you can do is you can probably specify a template like this, and then say Hasura, hey, when you're getting a query or a subscription, then you also go and check if the headers is having like X query read no stale is equal to true. If that is true, then don't query read replica, instead go to the primary database. Okay, this is an interesting question. Do I need this? Right? It's a bit tricky to answer. What I would say is, if your requirement matches with any of these following questions, then you should definitely try this feature, or you will make use of it. Do you have a data distributed or cloned between different database systems? Then you should try this feature. Are you not happy with your database performance and planning to implement different sort of database topologies? I would say you must try this. Do you want to use different database connection configurations for specific type of users? You will make use of it for sure. Have further questions? Do reach out to us on Discord or GitHub, or maybe in the chat, or even write to me on suraj@hasura.io. You'll find a lot of interesting use cases and a lot of possibilities by reading through our docs. It's available on the official Hasura docs page. Thank you. Thank you, everyone.
Thank you, Suraj. That was excellent as always, very informative, and we're excited about those new updates coming through. So are you ready to talk about input validations today?
Hey folks, so I think couple of months ago, before I guess 2 months ago, we showed a preview of what we are thinking about for input validations, and we had a draft RFC put up in our GitHub repo. We got few very important and interesting comments, and we have also been hearing about it on Discord. So this very excited to see like so much enthusiasm for this feature. And today I'm very pleased to like show you a preview of the feature itself. We'll do a live demo of a few use cases of input validations for inserts, and the subtitle here is like being able to hook your validation logic in Hasura. And most of you would be knowing that doing validation for your data has been a little bit cumbersome with Hasura so far, and we hope to make that much more powerful, very easy, and overall like solve this problem for the majority of use cases out there. So first, I want to show you the RFC here. So the RFC is in this link. I think somebody would also share that in the chat. I want to show you some of the content in the RFC. We give some motivation and then we describe like what kind of validation we want for our mutations. A few alternate approaches. The behavior is also described, which we'll see very shortly in the demo itself. Specification of we'll see the specification of like the exact things that are required for you to set up on your end when you're hooking a validation logic. A few examples are also listed here. We'll see that live today and some enhancements. So in case you have further feedback or you would like this to be slightly different, you see some of the use cases which are not covered in this RFCs, please feel free to like leave a comment in the RFC itself. We have already gotten very nice comments from other community users as well. With that, let's jump right into a demo. And the first use case is going to be a very simple and the canonical use case for any kind of validation, which is you want to insert a user in your application and they have an email ID and you want to make sure that that email is a valid email ID. So this could be like any kind of form in your application, right? Or it could be like any kind of input getting from the API. So let's look at how the permissions are defined here. I put the metadata here. We don't have the console in the preview yet, but those of you who are familiar with the Hasura metadata would see that this is the insert permission that you would attach to a table. It has a role called user. It has a permission field which has like different types of permissions, right? Check condition, set conditions, column access. And the new thing that we are showcasing here is the validate input permission type. And this has something called type inside it, which is HTTP. So the way that we're going to hook our validation logic is through an external HTTP call. And since it's an HTTP call, we need some additional info like the endpoint address, right? So I'm running this on my local host. So I'm using the Docker bridge here and the path is called validate user. So let's look at how that plays out. So let me kind of clear some of this content here. I guess before we jump into the actual call, let me show you what tables we have. We have a user table. It has ID, name, and email, and it has a relationship with the articles table. And the articles table has something called content, right, and its own ID, the user ID, and this user ID is the foreign key. Now I want to just insert a user. So I'll use the insert user one command. I'm using the user role here and the accessor user ID. Let me just change it to some arbitrary value. And let me do a valid case first, right? So this is a valid email. So I should be able to insert it. That goes through. But let me now change this to something else, right? This doesn't look like an email address and our regex will not accept it as well. And we try to insert it. And then it says validation failed, invalid email, and the value here, right? So where is all this coming from? All this is coming from our webhook, which I'm running here. I just want to show you the code real quick. So this is the validate user field. It checks. So there is a specification which is mentioned in the RFC. So it gets that data, it checks for the email row, and it has a check email function here, which is nothing but a regex, right? So this was the first canonical demo. The second one is about limiting the number of rows that you want to insert. So that's kind of validation. And what we want to do here is that make sure that whenever we are doing an insert, and in this case, I'll also show a nested insert, which is more complicated. We want to make sure that it only the parent object is only inserted with a single child object, in this case, one user with one article. That is the condition that I have in the webhook. So let me go here and let me do articles. So that's some content. Get a new user. Oops. So I'll put a. So I just inserted an article, and this went through because this was just one. But I can quickly change this to multiple articles. I get an error message saying user can be registered with only one article, right? So that was the condition that we had in our webhook. Finally, I want to show the last example here, which is the most complicated one, which is that you want to reject a mutation based on the values in the relationship. So this is a different table, although you can't see the name here. I've snipped it off, but this validate input is on the articles table, and the condition that I have here, let me show you that real quick, is that there is a content limit, right? So the endpoint is slightly different. It's a validate tweet, and the condition is that the content of the child object should not exceed 10. So let me come back here. First, let me remove these things. Let's just have one. And let's have a really long thing. Let's create. Yeah. So as you can see that it's saying content limit of 10 exceeded, and that's because this thing is the child object has more than 10 characters, and it rejects the entire mutation, right? So those were like 3 use cases which were meant to show like the capability that you have here. If like little bit more technically speaking, what Hasura is doing is that it's creating an execution plan where the first step is validation through your configuration through this webhook, and after that, once that is passed, the rest of the permission and the execution logic takes effect. And this way, we are able to also customize the error message. Like you can give the error message, which helps users figure out like what exactly is wrong in their input. So yeah, so that's the demo, and I'll be looking for any questions in the chat.
Thanks very much, Tiru. That was awesome. I know we're all excited about that, and it'll hopefully make our lives a lot easier on inputting or validating data that comes in. So thanks very much. We're going to go ahead and move over to Rishi next, who I'm going to go ahead and pull on stage with me here. Rishi, how are you?
Hey, how's it going?
Doing well. You're going to be talking about Schema Registry today, which are some exciting new updates. So I'm going to go ahead and unshare my screen and turn it over to you and hop out of the way.
Yes, let's go. So Hasura GraphQL Schema Registry. I'm Rishi. I'll be talking about this new highly anticipated feature that we've been working on lately. This is a highly requested feature by a lot of our users, especially the users who've been using Hasura at a very large scale and across different teams being collaborated. Across different teams, across different organizations and things like that. So Hasura GraphQL Schema Registry, I tag it like reliability, observability, and predictability of your Hasura GraphQL schema. So what exactly is Schema Registry, right? So schema registry is a version history of all the GraphQL schemas of your Hasura instance with a detailed observability into its changes, right? In this schema registry has every single GraphQL schema that has ever existed on your Hasura instance, with details about how each schema changed things from the previous state, right? You can see there's a screenshot that will get into later, but for different roles, you can see how many breaking changes, how many different kinds of changes were there for when the schema was introduced. So before I go into why schema registry and why we are putting efforts into this and why it is valuable, firstly I want to say GraphQL is awesome. We've been saying that for a long time now, but there's a couple of points I want to reiterate anyways. So firstly, GraphQL has a very strongly typed GraphQL schema. It it the spec itself enforces a strongly typed GraphQL schema, and the contract, the protocol says that there has to be a strong contract between the operations that the client makes with the GraphQL schema, which means the operations, that is queries, mutations, subscriptions, can be validated across a GraphQL schema. That is, given a GraphQL schema and given a GraphQL query, you can tell if this GraphQL query can be executed across this particular GraphQL schema. Is it a valid GraphQL query? If it is not a GraphQL query, right? And this whole idea itself is very powerful because it allows a whole lot of pre-checks, validations, and cool features like the schema registry, right? So why schema registry? Let's talk about it with a tiny example. I have like a tiny an example data model, book and author. Book has ID, name, genre, author ID, and it's related to the author table, which is ID, name, date of birth. And looking at this data model, if you connect Hasura to it, it will infer a GraphQL schema like this. Hasura will actually infer a much more larger and elaborate GraphQL schema, but this is just a tiny snippet that I've picked out of this. So if you see, there's query root, mutation root, subscription root, and the mutation root has insert book, through which you can insert book into the book table, and then there's a query root field called book, which gives you the list of all the books from the book table, right? And this is the type of the book. This is the type of the book type. This is the type of the book as inferred by Hasura from the book table, and this is the author, right? At looking at, like, with this schema, these queries can be executed, right? You can have this query to get books, book, asking for ID, name, and genre fields, and then you can also have a mutation to insert a book into the books table. So so far so good. Now say you make some change to the underlying data model, right? Our data model was this. So now say you make a tiny change that the genre field becomes mandatory in the book table. So this genre field will, now it's nullable, it becomes non-nullable. Then say you want to change the name field in the book table to title, and say you add a computed field on the book table called score, which is the rating of the book or whatever, right? Now when you do this, the GraphQL schema generated by Hasura changes, right? It looks something like this. The name field goes away, there's a new title field now, genre becomes non-nullable from nullable, and there's a new field called score. So now once you do this, you can, without running these queries, you can tell that, hey, this insert book mutation will fail because now you need to enter a genre because it's not non-nullable now, right? And this query would fail because the name field does not exist anymore. And the type of the genre field has also changed. This is not very harmful because the genre field is still there. It has just become non-nullable now. So this is a tiny example of how, looking at changes in the GraphQL schema, you can tell, you can predict how the operations that are made to this GraphQL schema will change. Will they continue to work, or will they fail? So now this is a tiny example, but when you have like a very large schema, like multiple data sources, multiple remote schemas, multiple actions. So your Hasura schema is large, or say you have like a different Hasura gateway use case where you have like 5 different teams maintaining 5 different Hasura instances, which is federated by another single Hasura instance, and then the client queries that Hasura instance. In this case, the predictability of schema becomes all the more important, right? You really want a deep observability into your GraphQL schema about how it is changing and how it is affecting the client application and the operations run by the client applications. So why schema registry? Firstly, we want to, if you have a data API or a data platform powered by Hasura, you want to observe and avoid unexpected changes, and it becomes even more important when there are different Hasura instances maintained and developed by different teams, and they are federated. So it's very easy to break things in the gateway Hasura instance. And also finally, like when you are developing with Hasura, say you make some change, say you change a column name, or you add a new column, or you delete a column, or you make anything that affects the generated GraphQL schema, you can instantly go and check that, hey, what are the changes, what are the breaking changes in my GraphQL schema, and how will it affect my client applications. So this is the main motivation why we've been building the schema registry, and why a lot of our users have been requesting this feature, that this would really give them a peaceful sleep at night, that they would, like, knowing that they'll not break things unexpectedly. So we are nearing the completion of development. So I have some preview screenshot to share. Like this, as I showed earlier, this is the schema registry listing where you can see the list of all your changes, and we'll have detailed information about how certain schemas changed and how certain schemas of each role within Hasura have changed, right? This is the listing, and if you expand it, you'll have insights like this, that for this particular schema, admin GraphQL schema, this city field was removed from type customer, and these are breaking changes. These could be dangerous changes, and then there are some changes which are safe. So this is something we've been working on. It's coming very soon on Hasura Cloud. So do fill up this form. These assets will be shared with you separately, but do fill up this form to help us with your insights and feedback. If you're interested in this feature, you can let us know how we should improve it, how we should build it, so that it becomes more useful and more valuable. There's this GitHub issue that you can comment on, or let us know there what you think about this feature, how you want it, how you want it to shape up in the long run. And also you can get in touch with us through these mediums or through our Discord if you want early access on Hasura Cloud. We'll be launching it very soon, and we are really looking forward for feedback. That's it. Thank you.
And Rishi, thanks very much. We're all very excited about that, and it's going to give us a lot more insight into what's happening in our instances. That's awesome. So with the amount of time that we have left, we know that a lot of people are really excited about the V3 demo, and we really want to prioritize that. We got a couple of things that we're going to go ahead and move on to. So our panel that we had scheduled to talk about different enterprise features, we're going to do that towards the end, and we're going to do it in a much more kind of Q&A type format. So if you want to stick around and ask some questions, whether in the chat or whether we can bring some people up on stage, we can go for that if we would like to. But for right now, Martin, I'm going to go ahead and bring you up.
We're going to be giving a first demonstration of Hasura and MongoDB, our first foray into NoSQL. And this is going to be a quick demo of our first alpha program, which is coming out, at early next month. So I think the end of April, early May timeframe is what we're looking at for it. So here, without further ado, I'll just give a quick demo. So I'm going to drive through this pretty quickly, but yeah, this is my Hasura instance. I'm running locally. I've got my MongoDB database already connected. I've got a data connector connected for MongoDB as well. Over on this side, I've got the database. So I'm going to be creating a collection for users. We've got this cool thing here called validators, which are going to be what drives my my GraphQL API. It's how we're going to be able to figure out where, how to infer the types to start. And then I've got a bunch of records that we're going to introduce to the database. So we're just going to drop these in. So yeah, all of those things have been created up in here. So if I come back now and I go to my database in Hasura, we're able to sort of see that collection has been created. We're currently sort of just inferring that as a table. So we can track these. And then if we go to the API side, I'm going to do this very quick. We've got the sort of the schema that was identified as part of our validators here. This JSON schema has been kind of taken and mapped into our GraphQL schema. So from there, we're able to go all users. We can get a user query and return all the users that I just entered, and then use filtered query so that we can see it's Jane and Doe. Those two users have come back as well. So again, this is kind of like a pretty quick demo. It's pretty basic functionality that we're introducing via the MongoDB integration. But what this really is like our first introduction to NoSQL for Hasura. So again, as with all of Hasura's kind of integrations, we're really driving it in terms of performance. So we really want to have fewer round trips and send less data over the wire. Don't overfetch. So we're doing things like query field level projection for field level filtering. So you're only sending what you need. For permissions, we're going to be doing predicate pushdowns so that the queries are really responsive. We're only getting the data we need. We're not filtering at the server level. We're filtering at the database level, and then doing things for joins like using the lookup method or some of the things we're using for performance. One of the really interesting points of using NoSQL with a Hasura server, and something that we're really looking to get user feedback around, is migration. So currently, one of the biggest pains of Hasura is using the migrations within the system. So any databases you have, keeping your GraphQL schema in line with your database schema. So one of the really interesting parts about NoSQL that we're seeing is this ability to say that it's kind of evolving schema over time as your organization changes. So from this side of things, we're currently sourcing the schema from this validation system, which is within MongoDB. But later on, we're going to be also allowing the user to have a fully editable GraphQL schema, so you can change that in place and then update your system without any migrations. Also, the ability to have some tooling in there to sample what the schema should look like from documents which are currently available within the database. So these are some interesting developments that we're looking to do. We're looking to sort of give Hasura the superpowers of NoSQL, to really allow you to have that federation use case of pairing together your relational DBs, your external services, and NoSQL in a pattern. We're also looking to use a lot of these learnings that we've had from nested, unpacking nested JSON from documents to improve Postgres JSON B columns going forward. So you can kind of have an imagination of how we can sort of sprinkle this NoSQL functionality onto the rest of our database systems that we currently have in place. So that was a really quick demonstration of MongoDB, sort of a preview of what's coming in the future. We have an alpha program, which is coming. We're in April already, but coming in the next couple weeks, we're going to be launching it. So if you know someone who wants to join, if you want to join, that's my personal email. You can email, so martin@hasura.io. We also have an RFC that we just posted up in our Hasura GraphQL engine channel under discussions for an RFC for NoSQL data sources. So 9612, we'll link that in the description as well afterwards. And then we also have a form that we'll be linking in there as well, which is for signing up for the early access of our alpha program for MongoDB. So yeah, without further ado, that's sort of our presentation. We really appreciate everyone's time, and I'll answer any questions in the chat that might come up. So thanks.
I was going to say, it's no surprise, Martin. Everything's blowing up in the chat over there. People are really excited about Mongo. It's been a long time coming, so lots of cool things ahead. That's awesome.
Awesome. Thanks, everyone. Take care.
Keep the momentum up, and to kind of counter what happened last month in our community call where we went a little bit over, we're going to go ahead and actually shift our V3 demo up. So in a second, I'm going to bring Rahul on, and he's going to share with us some exciting things that are happening with V3. So Rahul, let me call you up on stage here. Welcome, sir. How are you?
Hi, Rob, and hi, everyone. And glad to see MongoDB finally on Hasura. Finally, fingers crossed. So let's go and talk about V3. Very excited here in the Hasura team to provide you a sneak peek into the next major version change of the Hasura platform, Hasura V3. And so we have listened to you. I think developing with Hasura right now is pretty easy. With V3, it would be even easier or better. And the main change which V3 is bringing from a developer experience point of view is the concept of having different builds created automatically for any metadata changes. So you now have the ability to have a code-first declarative experience to work with Hasura. You can author your metadata files locally, um, and iterate fast yourself or with your team, and even share builds without even applying it to your production environment. So each metadata change will result in a unique GraphQL API, which will be related to a build version, and those GraphQL API endpoints can be shared, um, and to have that fast iterative experience when authoring metadata. And the second aspect is that any of these builds then can be applied to projects. And now we are bringing this notion of always production ready cloud with Hasura, because the moment you apply the build to a project, it is a working GraphQL endpoint which can be shared with users. What you will get the moment you apply a build to a project, you will get observability out of the box, and you will go live in multi-region instantly. There has to be like Hasura V3 is multi-region out of the box. So this is what we will show you in the demo today. Um, and with that, let me bring up the new CLI for Hasura V3. So we have some limited commands right now. We'll be mostly using local and cloud today for the demo. So let me go first and create a local metadata project on my local machine. So I use the local metadata create command, and it tells me that, hey, a new Hasura project has been created in my local machine for me to start authoring metadata. And it is also asking me to now log in to Hasura Cloud. So let me go ahead and connect my CLI to Hasura Cloud. So I use the cloud login command, and I'm copy pasting my personal access token. So yes, very secure for a live demo. But so my CLI is now connected to the Hasura cloud. I'm successfully logged in. So let me build my metadata. Just a minute. So now the next step for me is, so my metadata project is created and I am successfully connected to Hasura cloud. What I'm going to do is now build my metadata using a project ID. Or let me first create a cloud project. So Hasura V3 cloud project create. So now what I have a project ID, and I have a console URL where I can start interacting with my project. Now what I want to do next is build this metadata with the metadata JSON file. So I have created a one model JSON file here, and I'm going to build that metadata. And after building the metadata, I am ready to, what it is giving me is a build ID. So this is a new concept we are introducing in V3. It is giving me a build version, and it's giving me a GraphQL endpoint I can test from the CLI itself right now. So let's do that. So you see that GraphQL API is working right now. And I'm saying, oh, this is great. Now what I can do is now I can apply it to my project and start sharing it with the consumers. So what I will do next is apply this metadata build. So project ID and build ID, the diagram which I showed in the beginning. The moment I do this, it's saying that, hey, the metadata build is applied, and hey, this is a GraphQL endpoint. You can start sharing it with consumers. So let's look at how it looks on the console. So if I go on the console, we have updated V3 with the new GraphQL, and this is that endpoint which just got spit out the moment I applied the build to the project. And let me execute a query. So I'm able to execute. able to execute this query. So on the new GraphQL. Now, just a minute. Yes, yes, Rob. Anything which I need to take care of while presenting?
Just going to ask if you could zoom in a little bit to make it easier to see. If you can just do like a command plus on there for us. There we go. And in the terminal as well, if we have to go back to it.
All right. Thank you for that, Rob. Let's go back to the demo. Got it. So now so now the fast iteration aspect of the terminal of V3 will come into play, because now I want to add more models or tables in my query. So I go back to my CLI. What I do is that I now create a build for a different metadata JSON file. So this is a metadata full model JSON file which I created before. Let me go ahead, and that build is successful. And after the build is successful, you could do a curl command on GraphQL or use GraphQL to test that API, but I'm not going to do it on the demo right now. I'm going to go and quickly apply it to the project. So the moment I apply to the project, this is an experience you are used to if you are a React developer or a Flask developer, that the moment you apply uh, your metadata to the project, you should be able to go and start consuming it on the console. And here it is. The console is refreshed with now all the models the moment I applied the new metadata JSON file to the project. And let me execute this query. And I'm able to run this query on console and even share this URL with my consumers. It's a production API ready for consumption. And then after that, the cool thing with V3 is that observability is out of the box. So this is behind the scene. I'm showing you the Google, our whole Hasura cloud account, where all the traces are being emitted based on that request path. So let's look at the kind of visibility we have. It took 13 milliseconds for Hasura to process that request, which is blazingly fast anyways. And if we look at within the server, parsing, validating, generating is happening almost in microseconds. So it's almost no latency added by Hasura during the request. And as you can see, most of the latency is being added by the AWS RDS we are using behind the scene. And even in that, you can see the kind of visibility we have, because I made a query which had 3 models and 3 fields being accessed. And you could see that I could go and if something goes wrong, let's say, hopefully did not go wrong on this live demo, but this was my way to go and then quickly check what happened. And this is where we want to go towards from a product point of view, is that provide you with these traces, distributed traces, so that working with Hasura even gets better. The second aspect of Hasura V3 is the multi-region aspect. So multi-region deployment is now out of the box in Hasura. And I will show you a demo, and then demo what we will do is we will run introspection queries from 3 regions. We will run it from US West, US East, and Europe West. In Hasura V2, which is not multi-region by default, you will see these kind of latencies from those 3 different regions. So if you're making a call from US West to Europe, it will be around 600 milliseconds. But with V3, you will notice a latency of around the same for all the regions, because the introspection query is being served from the region where you're calling it from. So with that, let's look at a demo of multi-region in action. So we are making a query from in V2 from US West 2 to US West 2. And it is giving me a latency of 82.1 milliseconds. Now I'm going to make a query from US East 4, and it is taking 311 milliseconds. Next is from Europe, to Hasura v2. And as I expected, because of the long distance, it will take a longer time, and it is taking 600 milliseconds, P95. Now let's look at v3. So US West 2 to West 2 should be, it was 82 in v2. It is already faster with 36 milliseconds. So same region, faster. Now let's do the same query from US East 2. And it is same, 41 milliseconds. And let's do it from Europe, which was 600 milliseconds with v2. It is 40 milliseconds. So this shows what multi-region deployment brings to you. And then let's look at what's last thing which I wanted to show you was the metadata aspect of things. So the core part of the new experience is the model-based or GDS-based metadata. So now the metadata has a structure which is much more intuitive to develop with. We have models which are nested not in databases anymore. So you could declaratively work on metadata without connecting a data source. And you have things like names, fields, and within fields you have a concept of field sources. This is the demo which I showed right now. And in the next community call, we'll be opening up for a private beta launch. Maybe before that, some people have already requested access to it by filling in the form, and I'll send that form on chat very soon. But wanted to give you a preview of what's coming soon. What's coming soon is a more, I would say, augmentation of the metadata model with permissions and authorizations per model. And secondly, this demo was done through a cloud database. We will do a demo with a local database with a new feature called Secure Hasura Connect. So these are some of the things coming up, and we are looking for any feedback, any comment you have. Is still early stage, and we can take feedback for making it better for you. So that was a sneak peek into Hasura v3. Giving it over to you, Rob. Thank you, everyone.
Thanks so much, Rahul. It should be no surprise that a lot of people are excited about this, not only inside the company, but also here on this call. So there's a lot of questions in the chat if you want to jump over there after I kick you off the stage here, and we'll get to answering some questions.
Sure, we'll do so. Thank you.
Thank you. Next, we're going to go ahead and shift over to our community demo this week or this month, and we have Tristan from Pysura. So I'm going to go ahead and bring him on real quick. And how are you?
Rob, I'm doing well. Excited to talk to everybody a little bit about some stuff we're playing with some Python libraries.
Yeah, I was going to say, I took a look at the README before joining on the call, and that's written in my kind of style, my kind of language. So I appreciate
Well,
the
there we
attitude
go.
there.
Yeah.
And so Tristan's going to go for about 5 minutes or so here through this demo. After that, we're going to go through and wrap up a little bit with some just kind of summary of everything. And then for those that came for the enterprise conversation, the panel that we were going to have on observability, security, and performance, we'll have that at the end for anybody that would like to stick around. So those 3 panelists, please stick around because I don't want it to be just me. All right. Tristan, on to you.
Awesome. So hi, everybody. My name's Tristan Hart, and today I'm excited to introduce you to a new open source library named Pysura. Pysura is the library to use if you're a Python developer using Hasura. I'm sure we can all agree Hasura is awesome. Never will I waste hours of my time on basic CRUD operations ever again. But as most Python developers out there that use Hasura probably know, the Python code gen is broken. This is a bit silly. Hasura's metadata knows all these important details, so code gen should be easy. With Pysura, it is. You can install Pysura from PyPy. After it's installed, just run the Pysura command to start the command line tool. When starting a new project, you'll need to run setup Pysura. First, the installer will help you provision a database and set up default tables for users and file management. Next, the installer will help you deploy a Hasura instance inside your own virtual private cloud, which it will set up for you. After that, the installer will deploy a default microservice with events that handle things like when a user deletes their account or has their role changed. Finally, the installer will build and deploy a template Flutter project. The second the installer is done, you'll be able to say you built an iOS app, Android app, and website. Congrats, you aren't just full stack, you're full platform. Pysura can do lots of useful things for you after the installer is done. One of the most useful things is the print Pysura command, which will print out your project's credentials to the console, making it easy to access Hasura, your microservices, and your website. If you add a new action, event, or cron in the Hasura console, make sure to use the import Hasura metadata command, and then run deploy microservice, which will regenerate new actions, events, and crons, and deploy them. After you update an action, event, or cron, you can run deploy microservice again, and your changes will be live. Say you decide to give Flutter a try, and after making some code changes, you want to deploy your website. Just run deploy frontend, and your website will be live. It can be a pain maintaining separate staging and prod environments for your projects. Not with Pysura. With Pysura, after running the setup Pysura command, you can run import existing Hasura and supply the Hasura instance URL and the admin secret to clone an existing Pysura project. It's important to note that Pysura projects enforce a strict but simple to understand naming schema for actions to prevent over-engineering. It's pretty easy to get the hang of. Every Pysura action follows a consistent and simple to use format. The reason this is valuable is because once you lay out an action in the Hasura console, by simply running the code gen, that action is ready to call and will return a successful response with null data. This means that your product team can integrate the platform code before it's written, allowing both teams to iterate at their own speeds. Let's take a look at a time lapse of the Pysura installer. First, install Pysura and run the setup command. Then, we create a new Google Cloud project. We provision a database, choosing things like how many CPUs to give it, what region it's in, and the amount of memory we want it to have. Then, we pull Hasura from Docker and deploy it to Cloud Run, specifying things like how much memory it should have or how many instances we want to allow Hasura to scale up to. From there, Pysura will set up Firebase for us and deploy a default Flutter project. This project will run on iOS, Android, and the web the moment we finish setting up. Pysura bakes things like auth and file management into the framework. Using Hasura events, it does things like change a user's JWT claims when their role is updated automatically, or delete a user's data when they delete their account, so you don't have to worry about things like GDPR. In total, the installation process takes about half an hour. And then it's just going to finish up this video. And then once the installer is done, we can navigate to our new website by clicking on the provided link. We can log in with test phone numbers, or if we wanted to, with an actual phone number. After we're logged in, we see the Flutter template project used by Pysura. We can perform some basic template queries and mutations, grab our JWT bearer token from the settings page, and more. Finally, let's say we want to add an action. First, we create the action in the Hasura console. In this case, I'm going to attach it to the default microservice by telling the action to use the Hasura microservice URL as its webhook. From there, we import the Hasura metadata and run the code gen. And voila, our action is live and ready to call. For anyone having doubts about Pysura, I invite you to check out promptpal.io. From idea to every platform in 3 weeks with just 2 devs. Thank you.
Tristan, thanks so much. That's really exciting. I don't know about everybody else here, but thinking about being full platform starts to make me think about how can I go ahead and start spinning up things that just go across everywhere with Hasura on the back end as well. So that's awesome. Thanks so much.
Yeah, absolutely. Thank you, Rob.
Yeah, absolutely. Like I said, just kind of the route that we're going to take for the remaining time that we have. I know we're buttressing up on the end of the call right now. I'm going to give a few community updates, and then after we're done with this piece, I'm going to call our panelists on the stage. For anybody that has time and would like to stick around, talk a little bit about observability, performance, and security in relation to especially enterprise. We'll go ahead and be talking about that. a few updates for you all. We recently had an event in New York, and we have a sequel coming to San Francisco very shortly, not too far off. It's going to be what we keep calling the Fancy Clancy down here in San Francisco. So there's a link that was just dropped into the chat over there. But come and learn a little bit more about Hasura, meet some people, have some food, have some drink, and enjoy learning more about Hasura and APIs. Additionally, we have a special launch event coming up on May 18th, and I've been told that's really all that I'm allowed to say, but I'm going to leave this on the screen for just a moment if you would like to grab that QR code. So some exciting things are coming down the pipe in the near future. All right. Additionally, HasuraCon is not far off. It's hard to believe it's been a year since last year's HasuraCon. You can see the virtual link there, the information. We're going to start posting updates very soon. Topics, all those things. And then once again, we're dropping the information in the chat as well for you all. As always, some helpful links for you. We're looking for feedback, and there's one that I'll add to this as well, just being from the docs team. Don't forget that we have a feedback component there, so please tell us all the things that you like or don't like about documentation, but then you have all the information here where you can share your thoughts on Hasura and the direction that we're taking things. All right, it does say see you for the next community call on May 25th, but like I said, I'm going to stop sharing my screen, and I'm going to go ahead and invite onto the stage our three panelists here.
No problem, Thiru and I look very similar. So.
All I see, I don't get video. I just get initials down there. I just start clicking around at things. So apologies there. How are you folks doing?
Good.
Doing great, and thanks everyone for hanging around.
Yeah. All right, so the three of you are here, and we're talking today kind of in the broad scope of just talking about Hasura Enterprise more than anything else, but really we're looking at three kind of critical areas: observability, security, and performance. And kind of, the way that we split things up is that each of you is, going to field some different questions. And we're trying not to make this rapid fire. So for everybody that's on the call as well, if you have questions that you want to add to what we're saying, throw them in the chat and we'll bring them up and we can answer them live and in person. But to begin with, we don't want to start too broad and say, what is observability, what is security, what is performance? So I think maybe a good place to start would be talking about security in regards to Hasura. So could anybody give us like a TLDR of how we handle and the different things that are available security-wise for Hasura Enterprise?
You want me to go ahead there?
Yeah, sure.
Yeah, so I think security is very top of mind for us and the users, and there are multiple features on the platform such as API limits, disabling GraphQL introspection, having multiple admin secrets, having multiple George secrets, able to configure allow list, and even a proactive vulnerability scanning for your projects. These are like some of the features we have around security.
So two things that jump out to me from that, I think, and I'm curious if anyone in the chat would jump in with similar ideas, are this idea about, multiple JOTs and then multiple admin secrets. So can you walk through like some examples of why that would be a helpful feature?
Yes, and I'll talk about multiple JOT secrets first. And there are two use cases which come to my mind why you would need multiple JOT secret. First of all, for large enterprise environment, you typically have multiple authentication servers. For authenticating certain set of users, their database is in one auth server and the other users are in some other auth server. So how do you get that consistent experience for your API? And that is where having multiple JOT secrets help in navigating that multiple auth server topology. Secondly, if you're AWS incognito customer, like some of our customers are, what AWS incognito does is that every time you create a new user pool, it gives you a new JWKS. So what do you do now? So you need this feature, multiple JOT secrets, to navigate that, I would say, design which AWS Incognito is forcing to consumers. And multiple admin secret is a different story altogether. So you need admin secret to do to run the console and do admin related stuff, but it is also a security vulnerability because admin secret, what if somebody, a malicious party takes it and does havoc with your database? So the whole aspect of rotation of admin secrets is enabled by the fact that you could have multiple admin secrets. And we recently rolled out some reliability improvements on the platform. And now rotating admin secrets causes no downtime. So even better.
That's exciting. Maybe just to kind of spread the love a little bit, we're going to go ahead and shift over to maybe observability or performance, and we can always come back to security if there are more questions there. But just kind of broadly talking, let's see, Nitin, are we talking with you about observability? Is that correct?
Yeah.
All right, awesome. So just kind of, my basic question, and I say this as somebody who spends a lot more time with the open source version of the product, right, or things in cloud, and maybe doesn't spend as much time in the enterprise area. So can you talk to us about the observability features that ship with the enterprise feature, the enterprise product?
So I think some of the key features are, which comprises of observability, is going to be monitoring and then tracing. Monitoring, we've seen quite a few users, including enterprise customers, use monitoring to scale their workloads, right? Based on incoming traffic, based on the number of WebSocket connections they have, they can scale based on that than the regular metrics of CPU scaling of sorts, right? We've also seen plenty of uses where we sort of have plenty of alerts set up whenever event trigger failures happen, whenever cron trigger failures happen, or any sort of system events happen. Those are some of these events which are also being published with these metrics. They're all published via Prometheus metrics. These can be scraped and then they could be integrated with any sort of alerting mechanism that the user might already have. The next part is the tracing bit as well. So we also have some open tracing integrations wherein folks can run an OpenTelemetry agent and they should be able to get some traces of how your queries are performing and what are the queries which are actually being bottlenecked, and they can dig deeper into it, dive deeper into it much easily. Rather than running blind and figuring out something is not working and trying to figure out which query that might be the cause. Right? This the entire observability suite sort of helps in tracking all these issues, figuring out what is going wrong in production.
Awesome. I did notice that you made one mention of Prometheus in one of your early parts of your answer. Could you expand on that a little bit?
Prometheus is sort of the industry standard at this point, where everybody's using things to monitor. So the GraphQL engine emits Prometheus, all these metrics in Prometheus metrics format. And then the users will then set up a scraping using any of the Prometheus agents, which scrapes these metrics, stores them in their data store, and then they can be queried over time series. Right? There's a time series database, and they can query and figure out and set up all sorts of alerts as to if there's a spike in traffic, if there's a spike in error rates, if there's a spike in if there's queries are taking a longer time, if you're experiencing failures, you can now set up alerts on all of these things and be alerted proactively than sort of reacting to these situations where somebody is coming back to you and saying that, hey, the API is being slow or the API is not working. And now you have a way of sort of proactively knowing that, okay, something is going wrong, and they can sort of add more nodes to it or fix these things within here.
That's an excellent transition, because if we're talking about being able to see, and really understand what's happening with our instance, then the next logical thing to talk about is going to be performance, and that's why we have Shahid here. So, just out of curiosity, right? There's some things that come to mind when I start thinking about performance in Hasura, especially when I'm talking about, again, the enterprise offerings, things like caching, things like re-replicas. So, Shahid, can you expand a little bit on how those help performance? And I'll just let you take it away from there.
Yeah. So the Hasura instance itself is able to handle a lot of requests at the same time, just by giving it more CPU or scaling it horizontally or vertically. And as always, it's going to be dependent on your database and how much the database can handle that requests. And to help with this, we provide a few capabilities like you mentioned, Rob. There is caching, where the responses can be cached on Hasura's side through a Redis instance that is configured with Hasura to just save that response for a brief amount of time that you can configure, and then serve the response from the cache, not hitting the database over and over for the same result set. And along with the caching, you can also do something like a read replica, where you could configure a few replicas out of your database if your data is always changing and caching for extended amount of times is not applicable for your use case. You could configure a read replica to distribute the load on your database so that you can serve reads out of those read replicas. And that combined with the dynamic database routing that Suraj had presented earlier will expose a very flexible configuration to be able to like redirect or direct traffic, several kinds of traffic to several kinds of your databases, to be able to distribute loads in very different kinds of fashion to get the most performance out of the system. And like Nitin mentioned, a lot of our customers use the Prometheus metrics and then other information from the Hasura systems to be able to scale, auto scale, and be able to handle the traffic seamlessly, so that Hasura is not bottlenecked on resources or any kind of those constraints.
I'm going to ask a very loaded question when it comes to caching, because I know the answer to this. How difficult or how easy is it to enable caching with Hasura?
Yeah, it's super easy to enable caching. All you have to do is to add a cached directive, provided this is available directly on Hasura Cloud. If you're using an enterprise version, you'll have to configure Hasura with the Redis instance. Our Helm chart comes back with the Redis instance. So just add the cache directive. By default, it'll be cached for a TTL of, I think, 60 or 300 seconds. I don't remember the exact TTL value. Yeah. So just adding a directive, it's as easy as that.
That's exciting. I always like when things are made easy for me. We have a question that just popped in. It says, any recommendations for real-time cache invalidation as opposed to TTL-based invalidation?
Yes. So Hasura also exposes the cache invalidation APIs. So every cache response will have a cache key associated with it through the headers. So you could track these cache keys, and then you could make an API call to invalidate a cache to the cache invalidation API endpoint with that particular key. So if you have a system through which you know that, okay, this particular cache needs to be invalidated, you can hit that endpoint and then ask Hasura to invalidate that particular cache as opposed to TTL. Yeah.
Super helpful. I'm going to pause for a second, see if any more questions come in through the chat. And if they don't, then I'm just going to ask, here we go. Another one came in. How does caching deal with authorization?
So the caching key is built based on the authorization, session variables that are derived from the authorization token, etc. So each unique response is stored as a separate cache key. So if you have a user specific response, that is saved in its own unique cache key. But if you have a response which is similar, which is exactly the same based on, like, for example, you're fetching a list of restaurants, right? And this is quite the same for a lot of users. So it'll be stored and served as the same response for all of these users. But if there is something specific that is dependent on authorization, that is dependent on a user ID, or it's dependent on like any other session variables, they are accounted for in caching, and then they are stored as unique keys.
Excellent. I tried to multitask and that got me nowhere. So there's the docs. Awesome. All right. Let's see. We'll give it a second to see if anything else comes through. I think we could probably have an entire community call that was just this panel having a conversation, because there's so much to be said about all these different topics. So maybe we've learned our lesson to try not to squeeze these things in. Maybe I'll call all of y'all out and we'll do a big panel one day. Nitin, Rahul, anything that you want to add?
Nothing else. I think we can always take more questions. A Discord, an email, or anything, and we can ask more.
Absolutely. Lots of ways to get in touch with us, and we're always looking forward to hearing more from all of you.
Yeah,
please, Rahul.
One thing about authorization. So in V3, we are thinking to circumvent that limitation which Shahid mentioned. So I posted a GitHub issue. Please feel free to know what are your ideas or what are the top requests around caching. We'll we'll make sure that we listen to you there. And secondly, kind of combining authentication, security, and performance together, there is a new feature we released, which is webhook auth caching. So, which is a cool feature because right now for each API request, you need to get the auth information from the authentication server. Now with this new feature, that authentication information is cached within Hasura, and which makes your round trips even faster. So leverage that feature if you're not already doing it. It was a big community uh, uh, request, and we delivered it a few weeks back.
Very exciting. A couple of questions came through there. Shahi, do you want to grab that?
Yeah, I think yeah, permission changes doesn't invalidate cache as such. I think you'll have to make sure that the cache itself is invalidated. So the recommendation here is for any kind of these use cases where permissions are changing, your metadata is changing. There is a cache clear all API in your CI/CD workflow. Just hit the clear all cache API when you have a permission change that you think is going to affect your cached requests, right? So there's a clear all API. With V3, like we plan to do a lot of these things automatically. Cache invalidation, automatic cache invalidation, edge caching, etc. Right. So yeah, right now with V2, this is currently an annual step you have to take care of.
Got it. Let's see. New question came through. It says Redis has streams, although it might be something that isn't needed as things are already plenty quick. Has there ever been discussions around caching subscriptions and connecting to a Redis stream?
Yeah, I think there have been like some pretty solid discussions around subscribing to an event stream and then using it to invalidate cache. We were just discussing about this yesterday at the office. So like amazing. I don't know what telepathic synergy of Core and Tristan here, but yeah, yes, this is one of the ideas we're exploring for V3. So yeah, definitely one of the things in consideration.
Excellent.
Can link to how we enable auth cache in enterprise. Yeah, I think.
Yep. I think I dropped a link higher.
Okay, right.
Yeah.
Just wait 1 second.
Hit the wrong link. Sorry, I can get it back. Just too excited today right now. Yeah, this one here.
Thank you. And that's a subsection of that, right? That's just for the session variables, but that entire directory is all about caching. So there we go. All right. We give it a count to 10 here and see if any new questions come through. Otherwise, I think we'll wrap up because we are well over time here. But I appreciate everybody's patience, everybody joining in for this panel and having this conversation with us. And to everybody on the call, thanks for sticking around, and have a great rest of your week and a good weekend. And we'll see you next month.
Okay.
Thank you, folks.
Bye, everybody.
Thanks.
Thanks.
Bye.